Now let's learn about the concurrent map in Java. So concurrent map is an interface in Java which represents a map that can be safely accessed and modified concurrently by multiple threads. It extends the map interface and provides additional atomic operations to support concurrent access without the need for explicit synchronization. Concurrent map is needed in Java to handle the situations wherein multiple threads need to access and modify a map concurrently. Concurrent map has a couple of implementations such as concurrent hash map, concurrent escape list map, concurrent linked hash map, concurrent navigable map, etc. Out of these, concurrent hash map is probably the most widely used one, and this should be sufficient for most of your practical use cases. So now let's have a quick code demonstration, and we will implement a simple feature using concurrent hash map which showcases how this concurrent collection can be used in a multi-threaded context. So here is a brief idea behind what I'm trying to implement for this demonstration. So I am planning to implement a concurrent cache, and basically there would be a couple of threads that will be writing certain values to the cache, and those threads will be reading the value from the cache, right? So how we could achieve this using the concurrent hash map is what we are going to build. So let's start. First we have the data structure that will be holding the cache, which is a map, of course, and it's a string. Let's call this as cache. This will be a concurrent hash map. Now let's implement the main method, and we are going to iterate from I as 0 to I9. So let's assume that this I value is the thread count, so maybe call this as thread number, and this is I. And what we will be doing is we will be creating a thread. So let's create this thing anonymously, and finally we will also need to call start on this one. So we have written start here. So first thing is we create the key, and the key could be a key string at the rate of value and then the thread num. What we will do is we will try to fetch the same key 3 times so that we could demonstrate that one time the cache is empty, so we are going to put the value in the cache, and for the next 2 times the value should be fetched from the cache, right? So in order to mimic that functionality, let's write another loop. So from j0 to j less than 3, j plus plus, and let's capture the value, which is going to be, let's say, a method called as cached value. Let's pass the key. We will implement this get cached value in a moment. For now, let's just have this method name itself. Now let's print some message here. So the message could be thread dot current thread dot get name. Let me format this one, and let's say key, pass the key value, and value, pass the value. So this should be it for the main method. Now let's implement the other methods, which is the cached value for now. So let's call this as private static string get cached value. Let's say the parameter is the key, and what we do first is that we try to fetch the value from the cache. So cache dot get key. If the, let's correct this spelling. So if value happens to be null, it means that the key is not present in the map. So we need to calculate the key somehow, the value rather somehow. So let's have another method for the same. Let's call this as compute. Pass the key. It's not implemented. We will implement this in a while. Now let's put the same value in the cache. So cache dot put key then the value, and finally return the value. Alright, so let's implement the compute method as well so that we can complete our entire implementation. So let's return this as a string. So compute, it takes a key, and first we print a message which is key not present in the cache. So I'm going to compute. Now let's put a try and catch block because we will be needing this. So now what we are doing to implement here is that we have a compute method and it's going to compute certain value. So we want to mimic the logic for computation, and so that will need certain time to execute. So let's mimic the same by putting a sleep here, maybe for 500 milliseconds, and once it's done, return the value, that is value for key. So I think this should be it for the entire implementation. Now let's run this one. So let me clean this up a bit. Alright, let's run this and find out its output. So what we see here is that the thread gets started, and first is that key 5 not present in the cache, so going to compute. Then key 0 not present in the cache, so going to compute. So essentially for all the threads from 0 to 9, the key has been created, that is key at the rate of 5, key at the rate of 0, so on and so forth. And in the first try they are not present in the cache, so those will be calculated now, and once they are calculated they are getting fetched from the map itself, from the cache itself. So let's try to find this for key at the rate 5. So here 5 is being fetched, right? So for the first time it's being created by the compute method, and for the rest 2 times it's being fetched in this manner, wherein you have the thread 5 and the key is this one, and the value is value for key 5. It's same for the other keys as well, for example for key 7, for key 6, for key 4, and so on and so forth. So what we have implemented essentially is a concurrent cache, and the idea is very simple, that there are a couple of threads which are going to put certain value in the cache and get the value out of the cache. How it's being done is like in the get cached value implementation itself, we are trying to fetch the value from the cache. If it's not present, we are computing it and putting in the cache. If it's present, then this will not be executed and directly we will be returning the value. So the first call to the cache is a cache miss, and then the cache will be populated with the value which is being generated by this compute method, which is doing nothing. It just has a sleep timer of 500 milliseconds, and then the value is returned as value for this particular key. And once the value is put in the cache, then for the subsequent calls the cache is being queried and we are getting the value from it. So as you can see that we have not used any locks or synchronization and all those things. So it's a very neat implementation because we are using the concurrent hash map, and this particular collection is a concurrent collection and we don't need to handle any sort of synchronization as such. So that should be it for the implementation and the code demo. Now let's learn a few more things about the concurrent hash map. So let's understand about the internal implementation and working of the concurrent map. Let's break this into 2 parts. The first is the adding an element to the concurrent hash map, and the second is fetching an element from the concurrent hash map. And why we are learning about the concurrent hash map itself? The reason is that it's the most commonly used implementation of the concurrent map interface, and for most of the use cases this should be sufficient for you as well. So let's learn how the elements are added to a concurrent hash map. So as the first step, we start with hashing and determining the segment. Internally, the concurrent hash map is arranged as smaller segments. When a new element is added to a concurrent hash map, its key is hashed to determine which segment it belongs to, and each segment acts like a small hash map within the larger concurrent hash map. In the second step, the lock is acquired. So once this segment is determined, the thread needs to acquire the lock for that segment. This ensures that only one thread at a time can modify that particular segment. And in the third step, data is inserted in this segment. With the lock acquired, the new key value pair is added to the segment's internal array. If needed, the segment may resize itself to accommodate the new element. And finally, as the fourth step, the lock is released after the insertion is completed. This allows other threads to concurrently modify the other segments of the map. And likewise, here are the steps that are needed for fetching an element from the concurrent hash map. So here as well, the first step is hashing and determining the segment. When a thread wants to fetch an element from the concurrent hash map, it first hashes the key to determine the segment which it belongs to. And as part of the second step, the activity is similar to adding an element. The thread needs to acquire the lock for the segment that contains the desired key. In the third step, we search in the segment. Once the lock is acquired, the thread searches for the key in the segment's internal array. Please note that since only one thread can modify the segment at a time, the search operation is safe from concurrent modifications. If the key is found, the corresponding value is returned. If not found, null or other designated value is returned to indicate absence of the element being searched for. And as the final step, after fetch operation is completed, the lock for that segment is released. Here onwards, other threads are allowed to access and modify the map concurrently. So this process continues over and over again for all the data writes and reads from the concurrent map, and this is how the concurrent map works in Java. So as we can see that here the locking and synchronization of the concurrent map is on a very granular level as compared to the approach of synchronization or creating the synchronized collection, wherein the synchronization was being done on the entire map or the entire collection itself. So this is pretty much faster in that sense because we are not holding up other threads from modifying or interacting with the map. And this is the reason that concurrent map is a better choice when you are dealing with a multi-threaded context and you need to have some sort of map-based collection.